Convert the following system of linear equations into an augmented matrix. So we need to introduce appropriate coefficients and then make the necessary changes to go from this system to an augmented matrix. First step is usually copy down your system. And there are no x1s in the first equation, but it's minus 3 x2s, and plus an x3 and negative 11. x1, 2x2 minus x3 was equal to 3, I believe. Just quickly double check. Is equal to 5, my mistake. And then 4x3 equals negative 8. Okay, so there we go. We've got our system here. Now what do we do? Well, I usually start with the easy things. Put some brackets around here, get rid of those equal signs, and replace them with the bar. Okay. Now we've got, well, a bit more to do. We should add in variables that are missing. So there are 0x1s in the first equation, 0x1s and 0x2s in the last equation. We should introduce coefficients where there aren't any written. So this is really 1x1, 1x5s, 1x3s, and minus 1x3s there. And now the last thing to do, and this is sometimes overlooked, so I want to make special mention of it, we need to, when we're working with augmented matrices and what they represent, we need to sort of assume that it's plus signs adding up coefficient times variable, coefficient times variable. But you'll notice up here we've got 0x1, coefficient times variable, minus coefficient times variable. We don't want that. We want it to be plus, so we change it to a plus negative 3, plus negative 1x3s in that second equation. So when we do that, now we all agree, okay, there are always going to be plus signs. So the numbers here just represent coefficients. We can just get rid of the plus signs. The first column of numbers is the coefficients for x1, so we don't really need the x1 written there. Don't really need the x2, don't really need the x3. And in this way, we can work with our system while writing about half as many symbols to represent it. So there's our final answer, the augmented matrix representing that particular system of linear equations.